Okay, question 7. We've got something moving in an orbit. So the force that keeps the object moving in a circular path is known as, so we know whatever this is that's moving around has inertia. I'll label that I. This is Newton's first law of motion. Objects that are moving want to keep moving. Objects that are moving, that aren't moving, want to stay still. So this has got inertia, and we're going to call that also velocity initial. Okay, so it wants to go in that line. Well, the thing that's making it go that way is the force inwards, which we know is gravity. And you've done this before. This is the centripetal force. That's a centrifugal force. So clearly, we're looking for either the word centripetal or gravity. No, yes, done. Okay, next part. So draw an arrow. Well, I've got all of this garbage here. There's my final answer. Gravity of my centripetal force. It says the object is moving at a constant speed. Why is it not moving with a constant velocity? So our first part we've got to say is, well, velocity is a vector quantity. So velocity is a vector quantity. That's one mark. And we can then say what's the best way I'm going to word this? So what's it say? The object is constantly changing direction, so has a changing velocity. So this is known that vector quantities have a magnitude or a size and a direction, and this is constantly changing direction despite going up the same speed all the way around. Okay, next question. Figure 12 shows a skier on a slope. There they are there. Gorgeous. The skier travels down the slope with a constant acceleration. So I'm just going to put some things on here. A, perfect. It says the speed of the skier is measured at points P and Q. So speed, well, I'm going to change that to velocity. And you've looked, well, I'm going to have a final velocity here and an initial velocity there. So already now I can see, well, I've got a choice in terms of the question. I'll read in a second. I'm either going to be using a equals v minus u over t, or I'm going to have to rearrange v squared minus u squared equals 2ax. And that depends on if the question is going to give me a time or if it's going to give me a distance or a displacement. X stands for displacement, so distance with a direction. So x is the vector quantity of distance. Here we go. I'm having a look now. I've got acceleration, speed, and that. Okay, it says calculate the distance. So there we go, not calculate a time. So I know I've got to use that one. Use an equation from the list. So I'm just going to put that there. So I know that my equation in the list, they'll give me v squared minus u squared equals 2ax. I want to get x on its own. So 2 and a are going to have to disappear under here. So I'll just rearrange it. I've done loads of rearranging with you, and you've done it in maths as well. So I'm not going to go through the process of doing it. So v squared minus u squared equal over 2a. Now we're ready. X equals v squared. So that's your final speed. 24 squared minus 7.6 squared divided by 2 times the acceleration 3.0. So it's just making sure you pick out the final speed. So just having a quick check. Yeah, q is the final speed. And then I put that into a calculator. Ooh, there we go. Come back. Oh my God. Dodgy fingers. X equals. I'll put that into a calculator. Do that now. 24 brackets. 24 squared minus 7.6 squared. Closing brackets divided by 2 times 3. Garbage. Is going to equal, let's put that into my calculator again. There's no F, right? Just looking at the numbers. Oh, there we go. Equals 86 meters. And there we go. Now it wants to know the time taken for the skier to travel from P to Q. So clearly now we're going to need the other one then. So I said it's going to come up with both. So we know A equals V minus U over T. So I can imagine that in a formula triangle. A, V minus U over T. I now want to find out, oh, that U's rho P. I now want to find out T. So now I can go t equals v minus u all divided by the all divided by a, and now we're ready. So that's going to be 24 minus 7.6 divided by 3.0. 24 minus 7.6 divided by 3, and I've got 5.46, so equals 5.46, and then recurring, I'm going to go to 5.5 seconds. Is that the end of this question? Yeah. So I'll write that down there, 5.5. And there you go.